Hello, my name is Mikhail Khludnev. I work in Grid Dynamics. Grid Dynamics delivers many engineering services for huge e-commerce companies. I work in e-commerce search team, and this talk is some kind of problem definition for e-commerce search from the business perspective. So I tell you what we are doing for e-commerce search. So, okay, we will start from the reasons which makes the e-commerce search quite different to the classic information retrieval, to the classic search. Then I tell you how we do actually search. Then I tell you about solution for the general problem of information retrieval to pick in the right balance between precision and recall. And we end up with gathering summary understanding of the user from the search results. Okay, please help me to remind what is the two basic conceptions which Lucene is based on. So what is the two basic conceptions in Lucene? Do you know about Lucene? And the Lucene is based on two powerful conceptions. Do you remember them? What Lucene is about? Sorry? TF-IDF is called the vector space model, but before we rank our result, we need to do what? And after index, we need to retrieve result and then rank it. So the Lucene is based on two powerful conceptions: Boolean retrieval and vector space model. And the problem is that these both things works really bad for e-commerce search. They just don't work for e-commerce. Here's the reason. The Boolean retrieval is relies on the query syntax, right? When we can demarcate just search terms by the modifier, like show which term is mandatory, which is optional, to the phrase queries, and so on. And you can guess that no one actually search with advanced query syntax, right? Usually users search with something like this. You just put the many terms one by one, even it's a multi-word term, it just concatenate them by spaces, right? They don't use advanced query syntax. Forget about Boolean retrieval. Then with vector space model, we also have really big problem because vector space model is based on dictionary statistics, right, and on word occurrence statistics, right? And why it's really important for, well, why it's crucial for vector space model? Because vector space model is used to rank our results. So think about this case. We have two words, search phrase. One word hit one document and another word hit another document, and that's what we use vector space model for. We need to rank this result, to choose which of these hit is better than another. And to use this, we use word occurrence statistics, right? It's just how it works. And also the important detail, to have the statistic, we need these documents quite huge. We need them big enough, and they should be written in some kind of natural language. But what we have in e-commerce, here is the typical documents from e-commerce system, right? They are much more shorter. They are rather shorter. They consist of a few fixed fields, right? And language is not natural at all. It just enumerates few same terms like brands, colors, and so on. And the one important thing which we found is that multi-word terms, right? Using B-word or 3-word terms as field values is really important for e-commerce search experience. Okay, the next problem which we faced in e-commerce search is well-known polysemy problem. So how it looks in e-commerce. When we search for pink sweater, what do you expect to find? What's the expectation for this? What?
Sweaters that are pink.
Really? Okay. This is what you expect, but this is what actually text search engine finds for you, right? They capture some products from other brands we just has word pink as a in B-word term. That's how it looks like. I'm searching for pink sweater, but some of the search results are not pink at all. And this one, what's the reason? These are produced by brand Pink Lotus. Here's the problem. It's not pink at all, but it's really pink. And here's actually the rare case when the Solr developer can beat Google developer. It's a result from Google Shopping, right? You see? These two results are not pink at all. They belong to Pink brand and Pink Tartan, right? And how we do prefer to search on pink sweater, you see, these results are fairly pink, but you should say that this is not pink, but it is berry color considered as synonyms to pink. So I checked all these cases. Or use Photoshop, you know, to provide better looking slides. And you can believe me because brand Facet has not any brands with word pink in it, but you should trust me that we have pink brands on the site. So there was an opportunity to make a mismatch. So the Polysemy problem has opposite side, right? When we search for pink rows, maybe for gentlemen it sounds like collocating two colors, but in fact there is a brand Pink Rose, right? And we can make a really good guess if customer collocate these two colors. We can absolutely sure really sure that it's a brand, right? Here's how it looks like in typical search system, right? These two products are not belong to this brand, but what we can also see from the Facet Counts, we can see that vast majority of results are fairly correct. They belong to this brand and they're really great. And what we need to do to provide better user experience, we need to just cut this long tail of binary matches. You know, it will improve search experience really much. That's how we search for pink rows, right? We capture only this brand. And the next our finding that ranking, which is classic information retrieval, is really keen about, right? We can read the many articles and researches about comprehensive ranking model, which has been recently contributed for Solr. Right, but our point about this, that ranking doesn't really work in eCommerce search again, because look at this search result for red dress, right? All these results are fairly correct from the text match perspective, right? And how you can rank these results? It's just even impossible to rank results with which has high diversity, right? Because of this, we suppose that precision is much more important for eCommerce search rather than ranking. Once again, look at the Facet Count. The vast majority of results are fairly correct. They are good enough. And what we need to improve search experience, cut binary matches, cut the long tail of binary matches. This precision is also important for mobile experience, but not because of it's really hard to scroll really long search result, because as you saw already, faceted navigation became less efficient when you have long tail of results, right? You enforce customers to choose department instead of let them navigate through length of the dress, right? At least you lose few clicks if your results has high diversity. And our overall idea about eCommerce search, about our vision for this problem, is that we just try to get the user intention. We try to read their mind, and so on. And if we read mind really well, we can run some kind of merchandising action, and this action will not just upset user, but just improve the conversion rate. See, if we recognize that silver jeans is a real brand, we can show this splash page for this particular brand, but not jeans with color silver. Okay, here's a wrap up for Problem definition. So we've looked into what makes eCommerce search really different to classic information retrieval. We checked, we saw that nobody uses advanced query syntax, which harms Boolean retrieval. We've looked into polysemy problem, how it looks in eCommerce search. And we've looked into precision is much more important than any comprehensive ranking. So that makes eCommerce search really special. Okay, let's go to solution section. So that's how we search. First idea which we get when we start to doing the eCommerce search, that we give up with tokenization. So we think that multi-word terms is really important. They carry really important information. And what we stop to do is just we stop to give up with tokenization. So we use keyword analyzer, and you see how terms from our index looks in the Solr admin. Then when we search, when we have search phrase to search, we search for all shingles, right? So for all sub phrases, it's like query time shingling. Then here's our top secret matching criteria, or more formally speaking, the retrieval criteria. Right, we are searching for coverage. Right, we consider the document as a match if it's able to cover the search phrase by the terms. Right, so here's a case for match. So we treat only such document as a match. These documents are not able to cover one word. We do not consider it as a match. And here is a more subtle case with overlapping. So we do not consider overlap as a match too. So we are looking for full overlap. That's retrieval which we use instead of classic Boolean retrieval. And with this approach, if we index multi-word terms, if we search for shingles, right, we can have the multi-word synonyms works out of the box. So how it works, and it's a still problem for Solr and Lucene, but there are well-known patch which doing this, so we have multi-word synonyms fairly for free. Recently I found this white paper and was really surprised at how the concept search relevant to eCommerce search. So add this into your library, check, it's really interesting and relevant to eCommerce search problems. Staged search is about solving the general problem of the information retrieval. But before looking into this, we need to refresh our memories about information retrieval. So we need to define the precision and recall metrics first, and then look why the search engine tuning is a problem. Let's imagine we have some search system, and here's a set of documents which we expected to find, right? But in fact, our search system are not ideal, right? It searches something different, which just overlap with the desired search result, right? We can say that the middle intersection is a true positive result. Right zone is a false negative. It's a result which we failed to found, right? And the left zone is a rubbish which we returned, but we should not found this. Okay, you all should know this. So the precision is a ratio of correct result to number of totally retrieved document to number of document found, and recall is a ratio of our result ratio of expected results which we successfully found. So precision and recall is two metrics, and the interesting fact that you can easily have system with 100% recall metric. It's really easy. You can just return all results for any query, just ignore query, just return all, and you have 100% recall system. And can you advise me how to build 100% precision system? Do you have any ideas? So if you have, just give me a call. Don't speak to anyone. We can make really good business about this. Just nobody knows. So what is the problem with tuning? So once a day you realize that your system can works really better. There is some really valuable result for your business which you fail to find, right? Fail to retrieve. So and you tune some parameters and you start to retrieve this result. Everything pretty well, pretty good. But in fact, in addition to this valuable result, you start to return some rubbish, right? And it is a problem of search engine tuning. Then we need to look into what we're actually able to tune in our search engines. So the first parameter is changing the type of query, moving from conjunction to disjunction. It improves recall but harms precision. Clear, right? And we can add more fields into query generator, right? It will improve the recall and harm precision again. We can add some linguistic stemming and so on, synonyms, right? It improves the recall, harm precision. Okay, we enumerated the all parameters, and we need to provide some solution for this problem, right? And as always in engineering, if we cannot provide like silver bullet, which fits for all cases, we provide the solution for some particular problem, right? And we have a problem with eCommerce search, so we solve this problem for eCommerce search. Okay, and the solution really trivial. We introduce fixed query parser configuration, right? And then we order them by descending precision. So we put most precise parser on the top and the most loose parser end to the end. And then, as I already said, the solution is really straightforward, even obvious. We need to enumerate all this configuration and just return first non-empty search result. That's what we need. But by doing this, we dynamically adjusting our precision for any incoming query. So it's a win. But you should find the problem about this. You should say me what is the problem with this approach, with looping by query parser configuration and running queries again and again. What is the problem? Well, response time should be a problem. It's definitely a problem. It shouldn't work. It's really inefficient and so on. Okay, you're absolutely right. But if you look into theory, there's a famous DAG white paper, and we can find the formula which estimated the search complexity, and search complexity is linear for the length of search results, right? It means that on the first stages, which give us empty search results, the search time is really short, right? You know, we'll get few empty search results in a moment, and that fact allows us to use this enumerating at practice. There was a "it depends" disclaimer, which I put at the slide at the autumn, right? Because it was not true for mean should match constraint, but starting from Lucene 4.3, it's true for mean should match constraint too. So because of this, I stroke this node. So now it's true for everything. Okay, I can share some estimate about the real-life search system. So we can say that about half of search phrases will be handled by that query parser, by subphrase coverage query parser. And for 30% of search phrases, it's just unique search phrases, we need to omit one of the words to handle them by that exact query parser. And for 20%, we need to fall back to text matches. And once again, if we dynamically adjust precision of our search engine per every search session, we are capable to read mind of our search visitors. Right? We need to capture what they're searching for. The last part. Okay, it's about match spotting. Match spotting is a getting overall user intention from aggregating pattern from the search results. Let's look how it works. In the first part, we use Facet Counts to understand what actually user found, right? And it's some kind of metrics which we can use to understand our users. But Facet Counts is not informative enough. It gives not enough information for us. And there is a facility which gives enough information about search results. And you can help me to remember this. How we can how we can debug search results, really understand them really well, just understand which group, not really group. So yep, and debug query produce really huge dumps of information. So not all people are able to read them, but if you can read them, you can find that this particular document has been captured because user searched by this particular brand and for this particular product type. It's really important information, but explain algorithm is really heavy because it's universal, and because of this we can run it only for first results page, first page of search results. So what we need for e-commerce search, we need to merge these two conceptions. We need to go through all search results as facets do and collect as much information as explain collects. But it's not. We cannot do it as this. We cannot run explain for all search results because it blows our boxes. I want to just show how it works if we have some particular documents, right? These has 3 fields in each, right? And we have some queries submitted. Then this query hits some documents and it hits some terms in these documents, right? It looks something like this. And now I remove documents which has not been hit, and query which and terms which was not highlighted by that query. And if we look through these patterns, we can get them. Most of them are fairly the same, and what we really need for e-commerce search, we need to collapse these matching patterns. It looks like this. These are similar patterns, right? Collapse them and count. These are same, collapse and count, collapse and count. So that's what we have in result. It's like a facet, but it's much more powerful than facet because they show the search phrase recognition and just gives us some kind of weight for every recognition in real time for every search session, right? I don't think you need to expose this to the user because actually there's some information that you get from user, right? But there's many usages for this information internally, so you can run some business rule engine or use it as input for analytical engine. And here's an example how it works for business rule engine. You can make a really good guess that person search about this brand, and you can redirect them to this splash page. And yesterday I had a technical talk about scorers and about Lucene internals, and I didn't explain how to write this implementation, but I give all necessary details. All information was provided yesterday. So you can create a scorer which will return set of terms for current document. It's set of terms. It's actually a matching pattern, right? And you need to have a collector which will aggregate this information and collapse similar patterns. That's all for today. We've looked into what makes e-commerce search so special than classic search. We've looked on how we search and how we find the right balance between precision and recall for every particular query, for every user. And we've looked how to get the overall understanding of our user from aggregating matching patterns from search results. That's all for me. Do you have any question? I have a $10 Starbucks card for most interesting question. So participate. Now it's clear. Do you like it?
Good job.
Thanks. Okay.